Hello grade 12. Today we're going to be looking at another example of a question related to work, energy and power. This time we're going to be checking the activity 2 from lesson 6, term 2, and this question is coming from the Siyavula book. Okay, it's exercise 5, 3.1, page 244 from that book. This question said a 60 kilogram skier with an initial speed of 12 meters per second goes up a 2.5 meters high rise as shown in the figure. You have the figure at the bottom here, and that will help you a lot because you don't have to draw the figure. Find her final speed at the top, given that the coefficient of friction between her skis and the snow is 0.08. Now, there's a hint that they give you, but we are going to be talking about that a little bit later. So let's write some data that is not in the picture right on the picture. Obviously, you cannot do this one in the textbook, né? So you must redraw the picture in your notebook. Now, the mass of the skis is equal to 60 kilograms with an initial speed of 12 meters per second. The initial speed is here and is equal to 12 meters per second. Okay? Goes up the 2.5 height meters. It's given to you the height of the rise as shown in the figure. Find her final speed. This is the question mark. What you're looking for is right here at the top, given that the coefficient of kinetic friction is telling you that the kinetic coefficient of friction is equal to 0.08. Alright, so that is the data you have. You have to look for that speed. Okay, now before we go on, we're going to draw the free body diagram, alright? While the object or the skis is moving up this incline here. Now, remember to take the surface in which the object is moving as the x-axis. So we're going to be drawing the x-axis with an inclination which is equal to the inclination of the surface. This is the x-axis, and remember we are going to also take it as the displacement in order to help us with the angle between, if we need it, between the forces and the displacement. Now, the y-axis, be careful, it is perpendicular to the x-axis. Okay, that is the y-axis. Now, let's see what forces we have here that are acting on the object. So, what forces are acting there? Remember, note that the object is just sliding, so nobody's pushing that person up. So what forces are acting there? Okay, this is the normal force. There is the normal force. What other forces acting there? There is frictional force. And there is gravitational force. Right? Now, note, the same as previous videos, we saw that the gravitational force is not in any of the axes. So we have to break it into components in each of the axes. In the y-axis, then you have the component of the gravitational force in the y-axis, also called a perpendicular component. Now, let's look at something important here. This angle that you have here, this angle is the angle of inclination. It is the 35 degree. This one is 35 degree. Alright, so you can notice that the gravitational force in the y-axis is the adjacent side, and therefore will be cos of theta. So here, this one is equal to, sorry about the colors, let's quickly fix it. This is equal to the gravitational force multiplied by the cosine of 35 degree, and the gravitational force will be mass multiplied by acceleration due to gravity multiplied by cosine of 35 degree. You will need it later on. And here on the x-axis you will have the gravitational force in the x-axis. If you see, this angle is equal to this other angle here. These are alternated between parallel. This one is also 35, and you can see that it's the opposite side to the angle. So the gravitational force in the x-axis is equal to the product of gravitational force multiplied by opposite side, which is then sine of 35 degrees. If you break it down as we did with the y-axis, we have the product of mass times acceleration due to gravity multiplied by the sine of 35 degrees. Alright, now here we have two different options that we can use to calculate the final speed of this person. Okay, now we're going to do option 1, and probably in another video we'll explain option 2. Okay, so here let's say option 1, and because that lesson is talking about that option, we are going to start explaining with this one. Okay, this is using the law of conservation of energy. Now, the law of conservation of energy, the formula will be as follows. The work done by the non-conservative forces is equal to the addition of the change in kinetic energy plus the change in potential energy. All right, work done by the non-conservative forces. Right, now if we go here to the free body diagram, the non-conservative forces are the friction and the normal. The normal, in previous time, you see that doesn't do work. The angle is 90 degrees. So the only conservative force that does work here will be the frictional force. So we are going to calculate the work done by the frictional force. All right. So let's go there. It's the only non-conservative force that does work here. So this will be done, or this will be the work done by the frictional force equal to the change in kinetic energy. We can already break it. It's half mass final speed square minus half mass initial speed square plus, this one is not going to fit, so let's move it there. Let's move it there, and then let's also move this one so it looks better. There we go. So let's go on. Plus mg final height minus m multiplied by g multiplied by the initial height. All right. So this is what we are going to use. This is the law of conservation of energy. It's the work done by the non-conservative forces. Okay. So let's first of all calculate and start looking for the work done by friction. Okay. Now, how do we calculate the work done by friction? Work done by frictional force is equal to the product of frictional force multiplied by the displacement multiplied by the cosine of the angle between the displacement and the frictional force, and remember it's going to be 180 degrees. Okay, so now what the problem is here, we don't have the frictional force. Now in previous videos we recall that frictional force is equal to the product of the kinetic coefficient of friction multiplied by the normal force. Once more, we do not have the normal force, so we need the normal force. Now, to calculate the normal force, we are going to apply Newton's first law of motion in the y-axis. Now, why in the y-axis? Because the normal force is in the y-axis. What are the forces in the y-axis here? This is the y-axis. You can see the under. Those are the y-axis. So the forces that you can find in the y-axis are the normal and the gravitational force, or the component of the gravitational force in the y-axis. Okay, the object is not moving there. The net force is 0 in the y-axis, and therefore we use Newton's first law. Okay, so now Newton's first law states that the net force is equal to 0. Right? What forces are there? Normal force minus the component of the gravitational force in the y-axis, that is equal to 0. If you go on, you find out that normal is equal to the component of the gravitational force in y, and that is equal to, it is shown here in the free body diagram. There it is. This is the product of mass times acceleration due to gravity multiplied by the cos of the angle is 35 degree. Angle is 35 degree. Okay, so we can calculate normal. Let's substitute everything and calculate normal. We have the mass is 60. Let's see quickly. 60 multiplied by 9,8. Right. 60 multiplied by 9,8 multiplied by the cosine of 35 degree. Let's look at our calculator. Is 60 multiplied by 9,8 multiplied by the cos of 35. That is equal to 481,66. We are here. Let me erase that one. It is 481,66 Newton. This is the normal force. So now we are going to substitute this value in this formula so we can calculate the frictional force. Okay, so let's go to frictional force. No, frictional force. Let's do it here. Frictional force is equal to kinetic coefficient of friction multiplied by normal. This is equal to kinetic coefficient of friction. Remember it was 0,08, but let's show you quickly. 0,08. 0,08, and the normal was calculated here is 481,66. Alright, so that is the frictional force. Let's use the calculator once more. Here it is 0,08 multiplied by 481,66. That gives me 38,53. So the frictional force is equal to 38,53 Newton. And this value here is going to be later on substitute in the formula of work done. Okay. Now, however, we have a little problem here. We also don't have the displacement in the question. Now, please note the displacement is the distance that person is going to cover from here, which the initial speed is 12 meters per second, to here, which is what they want to know. They want to know what is the speed of the ski when he arrives to this specific point. All right. Now, to do that one, let's quickly look at the following sketch. Okay. So now this is to calculate. This is to calculate the displacement. Let's look at the following small sketch. Okay, the displacement will be from the bottom to the top of the incline. We have that the height of the inclination, this one here, is equal to 2,5 meters, and this is the height. This is h. We have that this angle here is equal to 35 degrees, and we are looking for the distance that we have here. This is delta x. No, this is a triangle right angle, so you can use the identities here to calculate delta x. This is the opposite side, this is the hypotenuse. Okay, so you can say that sine of 35 degree is equal to opposite side over the hypotenuse. What is the opposite side? H. What is the hypotenuse? Delta x. If you rearrange this one, you get that delta x, the displacement, is equal to h divided by the sine of 35 degrees. Okay, now we can substitute the values. Actually, this is 2,5 divided by sine of 35 degrees, and if you go to our calculator, it is 2,5 divided by the sine of 35 degrees. That gives me 4,3586. So we're going to round off to two decimal places, will be 4,36. 4,36 meters. This is the displacement the object is going to cover, and that number is going to be substituted in the equation of work done by the non-conservative force or the frictional force. Okay, so let's now rewrite the equation right here at the bottom. Right, we have that the work done by the frictional force is equal to frictional force multiplied by displacement multiplied by the cosine of 180 degrees. This is equal to frictional force. Frictional force is equal to frictional force is calculated here, 38,53 multiplied by the displacement, which is right here, is 4,36 multiplied by minus 1, which is the cosine of 180. All right, let's go to our calculator, and we have here 38,53 multiplied by 4,36, and that is times negative 1, that is equal to 167,99 negative, because multiplied by negative 1. So this is equal to 167,99 joules, and that is negative. That is the work done by frictional force. So now we can go and substitute everything else. All right, so remember, we have this one here. Okay, we're looking for the final velocity or final speed. That is what we're looking. So let's start writing. Let's rewrite the equation here before we start substituting everything. Okay, so the work done by the frictional force is equal to half mass final speed square minus half mass initial speed square, everything plus mass acceleration due to gravity final height minus mass acceleration due to gravity initial height. All right, so let's substitute the numerical values. We have the work done by frictional force is negative 167,99, and this is equal to half multiplied by the mass, which is 60, multiplied by the final speed square, that is what we're looking for, minus half multiplied by 60 multiplied by the initial speed square, which is 12 square. Let me show you here. Remember, it is 12, that is the initial speed. Okay, and everything plus 60 multiplied by 9,8 multiplied by, sorry, let me just fix this one, plus 60 times 9,8 times the height, which is 2,5. Now, let's note something. The initial height is 0 because it is starting from the ground. So everything here is 0, right? The initial height is when the object is at the beginning, which is here. There is no height at all, so the initial height is 0, right? I'm not going to substitute because the space is small, right? So the rest of the work here is just do the calculation. Okay, so I'm going to do the calculation step by step, but the video is already a little bit long. So now we have here, we have here minus 167.99 is equal to, this is 60 divided by 2 is 30, the final square, minus this product here, 60 times 12 to the power 2 divided by 2, this will be equal to 4,320. You can check with your calculator, okay? Plus, and the product of 60 times 9,8 times 2,5 will be equal to 1,470. You can always check with your calculator, okay? So now, when you when you subtract these two numbers, this will be equal to minus 2,850. Okay, so now if you sort out this other part, you have that final speed is equal to square root of 2,850 minus, this one is going positive to the other side, minus 167.99 or 99 divided by 30. The final answer for the final speed is equal to 9,46 meters per second. This is the final answer of the question. The calculations, I didn't want to do it because the video is getting long and you can always recheck the calculation. Okay, so thank you very much. This is the complete solution of this question. It might be a little bit tricky, so I hope you did understand. You can always write a comment, and thank you very much. Next time I will do the same activity but using the work energy theorem. Okay, thanks a lot.